For example 6, we need to look at some terminology here. It seems a little counterintuitive. It says a blank is a region bounded by an arc and its chord. That region is called the area of a segment. So this two-dimensional space in here is called the segment of a circle. It's that space between the arc and its chord. Now that's a little backwards to us because we think of a segment as a one-dimensional object, but you're finding the area of a segment. Area is a two-dimensional measure. So it's a kind of an obscure piece of terminology here that doesn't make a whole lot of sense, but let's just go with it. Example 6, we are asked to find the area of the segment LNM to the nearest hundredth. So we see in this picture that we have a 120 degree arc, LM, which should correspond with a 120 degree central angle for angle LNM. Now, let's make this a little easier for us to visualize. I'm going to pull out this triangle because we know that in general to find the area of that shaded segment, we need to take the area of the sector, which we just talked about finding, and we're going to subtract away the area of the triangle. Okay, so the area of that sector, we could find that pretty easily. Pi times the radius of 9 squared, and then we're multiplying this by the fraction of the circle that we have. So 120 out of 360, that fraction reduces to 1/3. So we have 1/3 of our circle in this sector. We know that 9 squared is 81. So when we take 1/3 of that, it's 27. So the area of that full sector is 27 pi. So we'll just leave that alone for right now. We need to subtract away the area of this triangle, and this is where it gets a little bit tricky. So here is our rotated triangle. We have 120 degrees as the central angle up there, and we know that this radius is 9, so both of these are 9. My picture isn't exactly drawn to scale, as you can see, but that's okay. Let's bring down this vertical segment so that we know that it's perpendicular to the base of this triangle, which is serving as the chord. Because we know to find the area of this triangle, we need 1/2 the base length times the height. And let me write that over here. Now we're missing a couple things. We don't know what that full base length is. Instead, we have the diagonal radius, which is serving as the hypotenuse in this right triangle that we're going to use. So let's think about this. When we drew this vertical segment down that I have as dotted, we split that 120 degree angle in half. So we know that this is 60 degrees. We have the 90 degree angle right there. That means that this remaining part is 30 degrees, which gives us a 30, 60, 90 triangle. Now, our goal here, we have the longest side, the hypotenuse in that 30, 60, 90 triangle. Remember our ratios of x root 3, and 2x. The shortest side here is going to be this height that we really don't care about as part of our answer. We have the longest side, the hypotenuse is 9. We need to find this medium side here, which is going to be half of the base length. When we double it, we'll get the full base length b, and that's what we need for our area. So we know that I misspoke a minute ago. This x is also going to be our height, our h. Okay? So if we have the longest side, the hypotenuse, of 9, we know that x is going to be half of that, which would be 4.5. So our h value is going to be 4.5, and we can use that down here in our area equation. But importantly, we know that 4.5 times the square root of 3 is going to give us half of the base. So we could say that half of our base length is equal to 4.5 root 3. And when we double that to get the full base length, because that's what we really care about in this triangle, doubling the 4.5 takes us back to 9. So our base is going to be 9 root 3. So let's write this area equation out here. 1/2 times 9 root 3 times our height, which we said was 4.5. And this is going to get us the area of our triangle, which is subtracted away from the 27 pi, which was the segment or the sector area. So let's put these pieces together to get our final answer. Okay? And this is probably where you want to go to the calculator and type this in carefully. We're going to do 27 times pi minus 1/2 times 9 times the square root of 3 times 4.5. And just let the calculator take care of this, and our final answer, rounded to the nearest hundredth, we get about 49.75. And this would be in square centimeters.